what we do next is to assess how accurate our classification was. Is it, are we accurate? Did we miss something? Because when you look at the old image, you see we have defined like a boundary going around, and this is from the image. You see them, but when you put on our classified image, some of these are gone, though it tried to do it perfectly, but some of these are gone, really. So what we are going to do is to assess if our classification was good enough for us to actually go ahead and use it for the coming analysis. Now, given that we have finished using our training samples and we have already created our signature file, it's good that we remove we clear them, because if you see the image, when you put the image, you see little boxes in there, and you don't want that when you're working. So you can clear them so they go away, and then we go into our accuracy assessment. To do an accuracy assessment, we are going to create random points in this image. Why are we creating? Let me try to explain it like this. What is accuracy assessment? What we are
Hello,
asking,
Aisha.
so,
We have
yes.
a hand up. I don't know. Gerald, do you have something, a question or something? Oh, proceed.
Okay. So what we are doing with accuracy assessment is trying to see if our classification was good enough to actually give us what is on the ground that is actually existing is being represented by our classification. That is what we are doing. So what we are going to do is put random points on this image, then use those points to verify them with a known image. Yes? And usually what I use is Google Earth. So I'll make random points on this image, get those points and take them to Google Earth and check if those points were actually rightly classified. So on this image, if they're classified as vegetation, on Google Earth, are they vegetation? You get, that is what we are trying to do, and later on actually quantify our classification. Okay, so we create the random points. You come here. I use search all the time. You come in here and just search for random points, because we want to create. We don't create them physically with our hands. The computer, the software is going to do that for us. Okay, so you search random points, and we are still in data management. Create random points from data management. They want to know the location. I'll leave it the way it is in default. We need to give it a name. What is the name? Lake Opeta. Lake Opeta. Lake Opeta. Random points. You can name it anything. Okay. Then you can define the constraint or not, but you can still do Lake Opeta. And you have to specify how many points you want to be created. Okay. So when the software automatically puts 100, but do you need 100? Depending on the image you have, probably it's Lake Victoria, you'd need more. Or if it's a small area like a school, you don't need a lot like that. So you define how many you want. So I'm going to put 10. No, let me put 7 for demonstration purposes, and then say, okay. On the lower right corner, you'll see that it's working and looking for these random points, and they have been created. Now, when you switch off your image, you will see them. They are actually here. I don't know if you do you see that, Kasacha?
Yes, we can see them.
Okay, so they have been randomly just placed all over, eh? But we are hopeful that they are picking up all the areas. Hmm? So what
Okay.
you're going to do, now we have our shapefile for our random points. So what you're going to do is convert them to a KML so that we can import them in our Google Earth, eh? Because that's the only extension that Google Earth picks up. So what we look for our conversion tools, or you can just say layer to KML and say enter. Yeah, and that is in conversion tools. Eh? Okay, so you click on the tool and it opens up. You'd specify the layer you want to convert to KML, which is Lake Opeta random points. Yeah, specify where you want it to be kept and then run. Okay, so you check here, it's finished, it is being set. Hmm? Yes, Kasacha?
Yes, we are together.
Yes,
Okay.
we are hearing. Continue.
Okay. Now, I don't know if you saw that. When you go to our random points and check the attribute table, you see we don't have the values, the pixel values of those of our random points, but we need to know them because they're the ones you're going to be referring to. Yeah? They are the ones you are going to be referring to when we are in Google Earth. Okay. So what we do, we create, you come here and we are trying to extract our values. So we are just going to look for the extraction toolset.
So,
Let's
Madam
try it. Yes.
Aisha, before you proceed,
Yes.
a quick one from the chat section.
Mm.
Yeah, Gerard was saying, do you export the classified image to Google Earth? Or, but I think
No.
that it's what you're doing now, so it has been answered.
Yeah. No. No. We don't.
We are
We don't
getting points.
export.
Yes.
We don't export the image because the image is a raster. Eh? So it would basically cover up the whole Google. You won't see what is on the ground. So what we do, we create points, like representative points that we can go and import into Google Earth, and those points are going to be our reference points to know if because these points are representative of our classification. That's what we are doing. I hope that makes sense.
Okay, thank you so much. A second one from Karamaji. Are ground points picked? Is it the same as ground truthing?
Yes, that is what we are doing, but instead of going to the field, we are going to use Google Earth. But if it requires you, if your analysis requires you to go to the field, still create these random points to guide you when you're in the field so that you know, let me first remove this, so that you know that, for example, let me, I think, change the color of these things to a color I can see. Which color, Kasacha? Which color? Which color? Which color? Purple. And make it a little bigger, probably. Okay. So even if you're going to go and do the ground truthing in the field, you still need to create some random points that are going to guide you. So that you know this point here in this corner, on my classification, it's a vegetation. Or it is something. Yeah. And then you're going to actually prove that your classification was right, and on the ground it is still the classification that it found. You get?
All right, thank you.
Yeah,
I
that's
understand. Thank you so much.
you're welcome. And that's what you're doing, but instead you're going to use Google Earth. So what I was doing was to extract values, my values from my points. And I opened my in here and opened my um, extraction toolset, or you can just go direct and just say extract by points. Extract values to points, and it will come. We are looking for one in Spatial Analyst toolset. Okay, so you put in the points whose values you want, which is, yeah, the only ones anyway. You put in the reference raster, which is this one. Define where you want to keep this, and then go ahead and allow the computer to do this. Okay, so now this is the extraction. So our points actually extracted the values of these rasters, the value of the pixels in the raster. So I want to check the attribute table, and now we have the raster values. Are we following?
Yes, we are together.
Okay.
Yes, we are following.
Okay, that's fine. Now let's take our things to Google Earth to do a little bit of comparison. I'm going to stop sharing this screen and then share another one. Okay. I'm sharing another one now, and I'm opening Google Earth. Please let me know if you see my screen.
Yes, it is visible.
Yep, we are seeing it.
Okay.
Visible.
So,
I was
okay.
seeing it.
Okay. Just zooming into Uganda. This is Uganda. Okay. Then I'm going to import my KML, the one that I had converted. I just come here to File and Import. It's right here. Then come here. You see my thingy? And put to all files. Where are you? Here. Okay. So of course you have to navigate to the area where you kept your KML. Where did I keep it? Did I keep it in here? I hope so. No, I don't remember where I kept it. But let me check here on Google, on my arc. It's okay, it's in the default. Okay, so I just come here, import, and go to my default. What is the name of this thing? First change this to all files, documents. I'm just locating where I kept my work. Default. In here. What is the name? The name is Lekopeta Random Points. Let me see if I can get that. Lekopeta Random Points. Okay.
I thought, madam, you're importing the KML points.
I am importing the KML points. And I don't seem to, okay. Okay, they are here. Are we seeing what is going on?
Yes, we can see it.
They are green. I needed to find a better color for these ones, eh? Okay, so it's trying to find itself. So do you see it?
Yes.
Yeah. And it is located on bare land. That's bare land? Or what is that? Is that bare land or that is vegetation? Kasacha, what do you see?
Continue
Vegetation.
zooming.
Sorry?
Continue zooming. Do you mean where your cursor is?
Yeah, where that yellow piece is blinking.
I think that's bare.
Vegetation.
That's vegetation? Now that's the beauty of classification. Okay, so now wherever you're seated on your computer, you can decide what that is. And note that our first point is on vegetation on Google Earth. And then go back. I'm obviously switching back to my ArcMap. I'm not doing that for you. And check what it's coming up here with on the ArcMap, on your classification. You get the point.
Yes, we get the point. We get it.
Then you can click the next point. I need to have changed the color of these things from green to a color we can see, but it will work eventually. And so when you go to the next point, it's here. You see that? We are on Lake Opeta. Now, you see,
Okay.
this one looks like it's actually seated in water. You see? It's there.
Okay.
Yeah? And then you switch back to your ArcMap, which I'm doing, though you guys are not seeing me. But you check that point and see if it's in water. And yes, it is in water for this classification. Let me just share my other screen and then you see that too. Eh? Okay, let me just stop sharing this and then share. Technology. Okay, you see the screen now?
No, yes, it's loading. Good, thank you.
Thank
Okay,
you.
so you see that?
Yes.
This was our second point in Google Maps, the Google Earth. Eh? And you see in this classification, it is seated in water. Yeah. So you have to do this for all the points. For example, if you made like 50 points, you have to do this for all the points while taking notes. Yeah. Yes.
Okay.
Yeah. And then, make tables. Now, Kasacha, I'm going to stop sharing my screen. I hope you got the concept because Kasacha is going to share a presentation that I need to explain shortly before we go into questions.
All right. Let me share.
Let me stop sharing first.
Is my screen visible?
Yes, Kasacha. Yes.
Visible.
All right. Thank you.
Okay. So what I'm explaining, what I was explaining earlier, please go to the next slide. We are doing accuracy assessment. Eh? So, for example, in your classified image, we got our raster values. I hope you see the screen properly. And our water body has a raster value of 48, land, swamps, and all that. Yes? Now, what we are doing in Google Earth is picking up each point and saying this point is a vegetation, this point is a swamp, this point is a bare land, you get. And then we are going to put these Google Earth descriptions against the raster values of those points. But if you look clearly, you see that the raster value for vegetation here in the blue table is 91. Yes. So you see that this one was rightly classified. This one was rightly classified, but this one here, the third one, actually is classified as vegetation, but on Google Earth or when you do your ground truthing, it's a swamp. Do we get that point? So in ground truthing, we are having a contradiction here that our classification is not actually sitting on the right points. That is okay. Yes? So if you get this concept, then go to the next slide, please. So what we do is we plot an error matrix. Yeah? So when you look at this table, we have on your left-hand side, we have the water bodies, bareland, the actual values on the ground. And then we have the classifications here, the predicted values on the right-hand side. Now, what we are doing is comparing that how many of our points, our random points, did we classify as water body, and on the ground, they were actually water body. So in this box table here, it shows that we had only one. And then we ask ourselves how many water bodies that are water bodies on the ground, but we classified them as bare land. And fortunately, we had 0 all the way for vegetation, built-up areas, and swamps. Now we do that for everything, but you will notice that for built-up areas, there are some things we classified as vegetation, but they are actually built-up areas. Same for swamp. There are things we classified as vegetation, but they are actually swamp. I hope you understand this table here. And this table helps us to calculate our error matrix. So what you do, you add all the values in the diagonal center, because in the diagonal is where you have water body, bare land, which are the true classifications. Yeah. Add them up and divide, by the total. We are basically finding the average and then multiply by 100. So what you're getting is your confidence matrix, your error matrix, your confidence of classification. And in this example, you'll see that we got 81.5% confidence, and that is above the accepted classification error. So we can go ahead with this classification and use it for our further analysis. Are we together?
Okay.
Okay, Kasaj, I'm going to ask you to stop sharing because I need to go back.
All right. There we go.
Okay. So what I'm explaining, what I want to show you before we go into the questions is, where is my arc map? I'm trying to share my arc map.
We are waiting.
Yeah, it's coming. It's coming. It's coming here. Okay. Okay. Are we together?
Yes, it's visible.
Okay, now what happens in the event that you realize that your classification has overclassified? For example, you have 2 classes classified differently, but they're actually the same class. Let's take an example when I remove these random points. Let's take an example that the gray.
So, Harriet,
yes.
Madam Aisha, just a quick one.
Yes, please.
Yeah, what is the minimum confidence level of classification?
That's a very good question that I'm going to come to later. Let me finish this, yes?
Okay, then another one.
Okay.
From Karamaji. I have a question, Madam Aisha.
Yes.
Can we say the more you ground truth, the more accurate assessment, or the more the training samples?
Repeat that question, please.
Can we say the more you ground truth, the more the accuracy assessment, or the more training samples?
Those are different things that he's talking about, but I think what he's asking
Yes.
is the more points you have, the better accuracy level. Is that what he's asking?
Yes,
Or the more training samples you have, the better accuracy level. Is that what he's asking?
I think so.
Okay, so the more training samples you have, the better accurate your classification is. That is no doubt. But the points that you have for the random points you have do not bias your accuracy at all. You get? Because at the end of the day, it's a percentage. So, and it's an average. So even if you have 100 or 1,000, if they are wrongly classified, you're definitely going to have a low accuracy assessment error matrix. But even if they are few and they are rightly classified, they are still going to be high. So your random points do not bias your level of accuracy of classification. But the number of training samples, the more, the better. Because the more you're picking up the finer detail in your raster.
Okay, thank you.
Okay, so why I came in back here was to explain a few things about this raster data. When you look at this ML class image, this image here, on the you call it a legend or a key. It just has 1, 11, 22, 29. So we don't know which one is which. What is it though? You get? So how do we actually put data in here? And this is a raster image. Yes? So that is what I'm going to be explaining. So what we do is, first of all, add a field here for the name of each polygon that has been classified. How do we do that? You come in here and add a field. Now give it a name. For example, class category, classification category, class category. No, what is it? Is it an integer? I explained all these things. So this is a text, and it's good to give it an alias because the software always picks up an alias. And I always keep it the same anyway. Then define the length, depending on how much wording you're going to be doing. And we just make it 30 maybe, you never know. And then say, okay. So now you have a new field that doesn't have data. Now you need to fill the data. Yeah? We are going to use we are going to, oh, let me just open that again. We are going to first put that layer in editor mode, but it's not going to show up here. So you right click on it and edit feature. I hope you're following. So when you edit feature, it's now in editor mode. Now you can make changes on these columns. But imagine that you have 15 classes, or you have many polygons, yes? That you can't just write them in here. You can literally write in here anything. So let's say the first one is vegetation 1. Vegetation 1. And the second one is water body. This is manually, yeah? But what happens if you have many polygons? We can do it using a field calculator. How do we use the field calculator? You highlight your this column that you want to populate, that you want to put in your data, and then right click on it. Yes. And then come here. It's right here, field calculator. But this would also be very good. Now my example is going to be weird, but if you had so many values that you want to change, it would be good to first select those areas that you want to first, for example, if you have so many water body polygons, yeah, you would need to select by attribute. Come in here, probably select by category or any value, probably. Let's go with value. Say equal to, get some unique value and say 11. Imagine you have many 11s, yeah? Like the table that I just showed you, and double click on it and say, okay. You see, it would select all values that have 11. Yeah, like I want to minimize, remove this so that you see even on your image, they get selected, as well as your attribute table. And you can remove everything else by clicking here and have only the selected values. And still do the same thing, right click, go to field calculator and populate these fields automatically without you writing them physically. Yeah?
Okay.
Okay. And then say that the class category, which one? I mean, this one that we want to put in the data is equal to let's say water body. Water body. Say okay. Okay. What is it doing? Okay. Let me just put back everything and remove the, don't delete them, just remove everything and remove the highlight. Okay. But you get the point, eh? This is the bit of software. It does what it wants to do. So you right click on the column that you want to be editing and go to the field calculator. Define which column that you want, this one. Yeah. And then give it a name. Is equal to, let me try this. Now I didn't select anything, so it's going to do everything. Okay, let's try that. Okay. You will try it out on your own, but during the session, this is what you do basically. So we are done with the classification, and you have to get out of the editing mode all the time and stop editing. Okay, so I think Mr. Kasacha,
Yes, please.
we can go to the next, but I wanted to note one thing. If your
Okay.
image that you downloaded is like level 1 and it was not projected, then you have to project your raster data. You can just go in here in the search bar and check for raster projection. Okay, data management. And then put in the raster, define the coordinate system, and then you can project your coordinates. And also, if your raster does not have attributes, you see this is a raster, but when you open it up, it has an attribute table. But some rasters, for example, this one, let me see if we can use this one. It does not. It doesn't have an attribute table. You can make it have. You can create. You can activate its attributes to work with them for anything that you want to do, for example. So it's still in the data management tool. You still come in here and just build a raster. raster attribute. And then you get it and use it. Okay, so that's it for today.